This program is sponsored by Margaret College of the Holy Family, Parramatta.
Welcome to Educating for Success, and it's all being filmed right here at Margaret College of the Holy Family. My name is Sister Margaret, I'm the principal of the college, and today's episode we're going to be focusing on maths and science in the curriculum. We have two special guests with us today. Mr. Andre Sassine, who is the maths coordinator. Welcome, Andre.
Hello, Sister.
And Mr. Andrew Stillen, who is the science coordinator at the college. Welcome, Andrew.
Hello, Sister.
We're going to ask you a few questions in order for our listeners to understand better what the curriculum is about in regards to maths and science. So, Andre, can you tell us from year 7 to 10 what maths focuses on?
After the national curriculum came in, there's been quite a few changes. It's divided into pretty much three main topics or strands. The first one is number and algebra. Second one, measurement and geometry. And the third strand is statistics and probability.
Okay, and they're done across year 7 to 10? Or?
They're done across from right 7 to year 10.
Yep.
And there's subtopics under each of those strands. When we get to year 11 and 12, obviously we introduce other topics like calculus.
I'll ask about year 11 and 12 later on. Okay.
But pretty much these three main strands, and each strand's got its own subtopics from 7 to 10.
Okay, and Andrew, in year 7 to 10, what are the science?
Well, in 7 to 10, the new curriculum started last year, as that was with 7 and 9, and continued. The new curriculum continued this year with 8 and 10. We cover basically the four main areas in science, which is physics, chemistry, biology, and earth and environmental. And we try to split that up quite evenly in each of the year groups. So in year 7, they'll begin with a little bit on the skills, learning how to use the lab, all the safety, and then they'll break up into the four components. So we do some chemistry, they'll do a little bit of physics, some biology, and then earth and environmental science, which includes astronomy and space. Okay. And the same happens in each year, 8 and 9 and 10. And year 8 and year 10, they will do a major project, which is mandatory for the Board of Studies.
Is that new?
No, that continues from the old course as well, so that's been maintained from the old course. And in year 8, they can work as a group, and then in year 10, they do it as an individual project. So the skills that they are learning and developing in year 8 should take them through to year 10, where they can work as an individual.
Okay. Andre, do you want to explain a bit further the year 11 and year 12?
Year 11 and 12, depending on what levels they're in 9 and 10, they get to choose from the following: general mathematics in year 11 and 12. There's two types: there's general 1 and general 2. Year 11, the general 1, general 2 actually is common, so we just call it general mathematics. There's also mathematics, which is also a 2-unit subject, which is a higher level. And there's also extension 1 mathematics in year 11. In year 12, there's also, in addition to those subjects, there's also extension 2 mathematics. You have to be doing extension 1 in order for you to do extension 2 in year 12. General mathematics is divided into general 1 and general 2. Those students who do not want to take up mathematics later on in their career, they'll most likely do general 1 or drop mathematics altogether. And those students who want to pursue with their career but not heavily maths orientated, they'll stick with general 2.
Okay, and I suppose those who take on the extension maths are looking at a career in science or medicine or something like
Definitely. The mathematics subjects, if people want to do like accounting, most career options will involve pretty much maths, so they'll do mathematics. But if they want to do like engineering, where it's pretty much heavily maths orientated, they need to have at least Extension 1.
Okay, now we offer Extension 1, maths, Extension 2. Is there anything further than that?
Extension 2 is the highest level they can do, and in the old course they used to call that 4-unit mathematics.
Right. Yeah, okay.
Yeah.
Andrew, there's a lot of options in Year 11 and 12 for science, so do you want to walk us through them?
Yes, so it's an elective, so that the students can finish their compulsory science study in Year 10. Those that choose to go on choose as an elective, so they have the choices of biology, physics and chemistry. We can also offer senior science. That's a more aimed at the student that doesn't want to continue with science after school, but is still interested in science and is performing at a reasonable level. It's a little bit easier, and it's less specialised. Earth Environmental Science is also available. We have had that in the past, and even throughout the state, that's fairly not well patronised by all schools. So only a few schools do that. So we've tried it in the past, and numbers dropped off, so we don't offer it anymore. But biology and chemistry have been popular this year. Physics is really aimed at the top students. They have to be performing well, and they have to be very strong in maths as well. So they're the subjects that we offer, and we've had reasonable success in the past. We've got students now that have become practicing as doctors and engineers. So the students that really put their effort in will be successful.
I want to look a bit more into what biology offers, and given that Andre also teaches chemistry, you might tell us a bit about what they teach in chemistry. So do you want to, as a biology teacher, do you want to give us a few topics that are covered?
Yes, okay, so in Year 11 biology they begin with a look at the local ecosystem, and that's, we take the students out to a rock platform out at Harbour Beach. So they study some of the techniques that I teach them here on measuring populations, and they count little snails and weed, and they see the relationship between where the weed is and where the snails are, and how they feed. So they learn that. They learn to use the techniques that quadrats and transects. We move on. Currently, we're looking at patterns of nature, which is looking at cells and cellular structure and all the processes within the body. So a lot of practical work in this one. So the students are very busy in the lab at this stage. And then we move into history of life on Earth. And then we look at the evolution of Australian living things. And then that moves on to the HSC course, Maintaining a Balance. So that ties in a lot of the different areas, both for plants and animals, systems of the body. So we look at homeostasis, and we look at the excretory system. So the kidneys are dissected, and they do a study on that. And with plants also, how they survive in their environment. The Blueprint of Life looks at the genetics and evolution.
That's my area.
Yes, and then now we've just finished completing that. Now we're moving into the Search for Better Health. So that's on diseases. Okay. Which they'll be preparing an assessment task. They'll be picking their favourite disease, whether both infectious and non-infectious, and teaching the class about that.
Didn't they used to go to the university?
Yes, and we'll be attending the Museum of Human Disease very shortly to have a look at.
Where was that at?
That's at University of New South Wales. Yes.
That's it.
Yeah, and then the option topic we do to finish off is on communication. So that looks at nervous system, and more specifically on sight and hearing, and then how the brain works in coordinating. So that's the course, the biology course in a nutshell.
Quite full, isn't it?
Very heavy in content.
Thank you. Andre, given you're also a chemistry teacher, do you want to tell us a bit about the chemistry content for you?
Chemistry, we do a lot of the chemical processes, chemical reactions, and for the HSC course, we've completed the module production of materials. Students actually got to see different ways of making new materials, especially the polymer.
The lab work?
The lab work. Yeah. There's a lot of experiments. Every day there's almost an experiment that we have to do, and we also have to teach the theory behind it. It's very demanding, but very interesting at the same time. Students need to be working on a regular basis at home. If they don't do it, they find themselves they're way behind and won't do well. We've done very well in chemistry in the past years, and we'll continue to do well. We've got a very excellent group this year, and we're expecting quite a few Band 6s hopefully this year. We've done the acidic environment, and students looked at quantitative analysis, which we pretty much look at determining unknown concentration, unknown substances, and how much is in there. The technique usually involves titration.
Yes.
And for the first time as well, we entering our students, because it's such a good group, we're going to enter them in a competition titration, competing at other schools, and hopefully we'll come out with a win.
Hopefully.
Well, first time we'll see.
Yeah, and we at the moment doing chemical monitoring and management. We also teach the students a bit more on a qualitative analysis, see what's out there in the waters, in the soil, in the air, and how to detect all these heavy metals, all the new techniques. And we're doing an elective later on, which involves shipwrecks and salvage, it's called, and it's more further work on oxidation reduction type of reactions.
Yeah. Now, I know you also take them on an excursion to the Blue Scope Still.
Yeah, in Year 11, we take them to Blue Scope Still. It's part of the course. Very rarely schools take them industry-based type of field work. They went to Blue Scope Still at Port Kembla. It's probably one of the biggest metal sort of companies producing iron ore and the different types of metals. Students got to see from raw materials to the finishing product of all the chemical process that takes place at and it's like students actually find it more meaningful when they see it.
Yeah,
I mean, we do it in sort of at school, but when they go out there and see it themselves, they start to understand what's really going on.
Okay, we've talked about the curriculum and excursions that are associated with the curriculum. So let's kind of move on to a hands-on approach. Now, science, it's pretty easy to do a hands-on approach with experiments, but is there kind of a hands-on approach with maths?
Yeah, I've tried a different approach with mathematics in the last 2 years. We tried to use technology to our advantage. A lot of our students spend a lot of time on the computer, so we thought we're going to move away from the traditional textbooks and move into the e-learning.
Okay, I know in primary now they've moved away from
completely.
Textbooks and it's more hands-on. So
And I think within the next year or two, we're moving in that direction. We've introduced two digital web-based programs at our school, MathSpace, where it's an online program where students, if they have difficulties with any of the topics being taught, they can log on and look at the topic, and pretty much it will teach them all the content that they need to know. We put questions up there for students to do on online homework. It will never give them the answer, but it will tell them whether they are right or wrong,
Hints.
and it will guide them through system by hints. And that's how we learn maths. It's going from one step to another and learning why and how we get there. Another web-based program we've introduced also is My Maths Online. It's like an interactive type of software where there's already prepared lessons, even games and quizzes to make maths more fun and come alive, really. So that seems to be working with our kids. They seem to enjoy it. Initially, they were a bit hesitant because it's just a new way of learning maths, but I think now they're more comfortable with it.
Okay. In primary, they've also introduced mathletics. Are you familiar with that, or do you want to say anything about that? Or?
Yeah, I think just continuing with mathematics. I think mathematics more specifically with the primary. So building on that is those two programs that we have introduced. Yeah, I think mathematics is more suitable for primary than what
I think it's doing a great job in primary. Also, the students enjoy maths a lot more. We're going to take a break and we'll come back later on to continue our discussion on maths and science.
This program is sponsored by Maronite College of the Holy Family, Parramatta.
What do you do if your child has too much homework?
To make the learning for the students better, more engaging.
What do you do if your child does not have homework?
And we group the children as per their ability.
Do you prefer the traditional methods of teaching?
Here we've got interactive whiteboards in all of the
As well,
classrooms.
yeah.
If you want answers to these questions, watch our program Educating for Success with Sister Margaret Lawson, the Principal of Maronite College of the Holy Family, Parramatta, on Midpoint TV.
Welcome back to our program, Educating for Success. We have in the studio with us today Mr. Andre Sassine and Mr. Andrew Stillen. We're talking about the maths and the science curriculum. Andrew, science, everyone associates with science, experiments. Now we've got 3 labs and a lot of experiments happening. Do you want to tell us about some of the more interesting experiments that students enjoy doing?
Well, yeah, they start from around year 7, as I mentioned before. They really need to learn the basics. So they start to use equipment. They will start things by filtering different mixtures, for instance, and seeing that some insoluble solids can be captured there. Techniques, evaporation, simple chemistry techniques, and that all then builds on. They learn to use the microscope. So they can observe cells. So they find that quite interesting. When they move into the physics areas, they can start measuring things falling, dropping, bouncing, using stopwatches to measure time and speed. So they get a kick out of that as well. With the earth and environmental, probably more work at home, looking up at the stars at night, recording things, weather, that they're things that they can do at home. With the other year groups, things progress. They will start using power boxes to supply electricity to create circuits, understand how electricity works there. Also with light, that we have the light boxes where they can direct light rays and learn about all the properties of waves and light. So there's a lot of experiments involved in that area. Currently, I think the year 9s are also culturing some bacteria in the incubator. So that they were testing out certain detergents and soaps, washing their hands with it, using a dirty hand and a clean hand, and comparing by placing it on agar plates. So I had a look at, and there's some are developing quite well there. In year 10, they've been doing a lot of chemistry. So latest one we looked at was precipitation reactions. So they were quite fascinated to see that clear solutions can actually form a coloured solid. So some of them thought that was quite interesting. When we move into 11 and 12, now they become a lot more complex. We've got some that carry on for a number of weeks. So for instance, in biology, we are growing plants in different environmental conditions to see the effects of the environment. So they can be quite long experiments that need to be checked from time to time. Physics, we have lots of equipment there to use. However, we do take advantage of University of Sydney's Kickstart program, where they've got all the equipment there, which schools really can't afford, and students will carry out some good experiments there, which meet the syllabus requirements. So that's something that's very helpful for them. In chemistry, Mr. Sassine said there's lots there, titration, lots of chemicals mixing and reacting, and so there's always sometimes when the esters experiments are happening, we can smell the nice banana and fruity smells coming through. So that's all good for the students there. When we do run senior science, quite a variety of experiments there that the students need to perform. So plenty of hands-on for them. And it's just a matter of the students working at it, following the instructions, and trying to achieve the results that the experiments are trying to show.
That's right, the results and safety always is number one priority.
Safety, yes. We have a strong. We teach them in year 7, and we emphasise it each year. All the students have safety glasses. There's aprons available for them to protect their clothing and gloves. Some students may be allergic to certain chemicals, so always we wear the rubber gloves there at times when necessary.
Now, one of my memories of science back at high school was the dissection. Do we still do dissection?
Well, yes,
of
they
the
do.
heart or
Yes,
something?
Year 8 still do dissections of hearts.
Yeah.
So, yeah, they can look at the 4 chambers of the heart. They can also dissect flowers. So there's plants.
Not as exciting as
Not as
dissecting
exciting,
the heart,
but yeah, it's still using a blade. Which they again, safety. They have to be careful and have to be shown how to use it properly. Also, in Year 9, they do the brain.
Oh, they dissect the brain, do they?
Yes, which really, it's just really halving the brain so they can see the hemispheres and see basically the cortex, the medulla and the stem. So there's that, and I think, in Year 12, biology, we do the kidney dissection, which is good, and also the bullseye.
Oh, okay.
So we can get a little bit messy at times, but the students really enjoy that. Some do take a backward step and say, well, they can't be near it, but other ones are very, very keen and they get in there very close.
Yeah. Okay. I want to ask one more question with science experience. Back when I was in school, I remember, I think when I did biology, we had to take a chick that had just been born, hadn't seen its mum, so the first thing it saw was the student. I had a chicken, it kind of adapted to me and it followed me, and I was kind of like its mum for a week. I don't think they do that anymore,
No,
do
we
they?
don't. Yeah,
Imprinting, I think it was called, or something.
Okay, yeah. If you do experiments with live animals, there's a lot of rules.
That's right. I thought they wouldn't do it anymore because
right,
we asked them what happened to our chick after they took it out after a week, and I think it went to the slaughterhouse.
But sometimes, sometimes I do reminisce about some of the more explosive chemistry
exactly.
reactions. But with all the work, health and safety these days, looking after the children, some of those good explosive experiments are no longer able to be carried
remember
out.
chucking sodium in the sink when I first came.
Hydrogen sulfide,
That was quickly abolished.
Yes, the sodium explosion doesn't happen anymore. So, but we can still use a Bunsen burners and flame and little pop tests when testing for hydrogen.
Yep.
That's about as explosive as we get.
Well, maths I don't think is going to be as explosive, but Andre, do you want to talk us through the levels of maths that we do have?
Yes, the levels are from 7 to 10 mostly, because I've spoken about 11 and 12. We have stages. Stage 4 is really Year 7 and 8. We don't split them up into levels. We'll give them 2 years to really prove themselves, and in Year 9 and 10, which is called Stage 5, we split them up based on the performance that they've done in Year 7 and 8. We have, in Year 9, we have 5.3 level, which is the highest level, 5.2, which is like an intermediate level, and 5.1, which is the lowest level. So those students who aren't doing well, we'll put them in the 5.1.
Now, do they all cover the same topics?
No.
But in depth? Okay.
Unfortunately, it's different. If you're in 5.3 in Year 9 and Year 10, we do everything that 5.1 level does and 5.2, but also additional topics in Year 10 mostly. And these are very demanding in Year 10. The topics done, especially Term 3 and 4. Why? Because these students are 5.3, the highest level. They're going to do either Extension 1 Mathematics or Mathematics. So we need to give them the foundations. So the topics are really to give them the foundations that they need in Year 11 and 12. 5.1, if you're in 5.1 in Year 9 Maths, unfortunately with the new national curriculum, it does not really prepare you for senior studies of mathematics, even general mathematics. So if you're a 5.1 and you choose, say, general mathematics in Year 11, you don't have the right foundation, so you'll struggle.
Has the Year 11 and 12 maths been updated, or are they planning to update that to correlate with the changes made in...
For the Year 11 and 12?
Yeah.
Yeah, Year 11 and 12, general mathematics has gone through a lot of changes over the years. We used to have maths in practice and maths in society. It's gone now to general mathematics. And there's also plans in the next 2-3 years also to revamp the whole senior mathematics. There will be specialty maths. They're all going to be 2 unit, but they're going to have different names. So it's under consultation at the moment. So we wait for the next year or so for any feedback from the Board of Studies.
Okay. Thank you. Science. Now, looking at physics, chemistry, biology, so on, why would you choose those subjects? What career path do they lead you to?
Well, there's a lot of science-based courses available for the students. So, let's begin with science. So you can do applied sciences. You can branch off into all the different areas. So some could be engineering-based, some could be medical-based, some could be, say, sports-based, environmental-based. So quite a wide range that they can choose. So the students that maybe study physics may use that for engineering. The chemistry students may be more in the materials-based areas, and the biology students more in the environmental or more of maybe the human services side of things. So maybe some of the girls can use that for nursing, for instance. But of course, the pinnacle then is to head towards medical science. And although the Board of Studies does say that they can do a maximum of 6 units, I don't encourage it. It is very, very difficult, very high load of work, and really leads to students really stressing at the end. So a maximum of 2 science subjects generally will get you into any of the science courses, even into medicine. All right, so generally like a physics and chemistry would be more suitable for doing medical science. If earth environmental science were offered, then that's a little bit more limited to the geological areas and environment maybe. Okay. So again, quite a wide variety, and then some of the higher level ones like physiotherapy, pharmacy, veterinary science, dentistry are all available for students that really have to be achieving band 5 and 6 to be studying those subjects in tertiary.
Okay. Thanks, Andrew. And Andre, really quickly, I know you touched upon it before, but because like kids say maths, what do we need maths for?
What do we need maths for?
So where can maths lead you to?
Yeah. And that probably brings to the topic of how we make maths interesting, because students, if they don't see relevance, they get easily turned off in mathematics. I think us teachers here, what we're trying to do, and we use technology to our advantage to try to get them interested. We try to make it more meaningful for them. We keep telling our students every time we teach a particular topic, we try to highlight the area used in everyday lives, whether they are behind the desk, working for McDonald's, whether they are pretty much they've got a part-time job counting money. We try to tell them that maths is everywhere. Wherever they are, they need in their homes as well. Look, we actually there's a whole topic on consumer arithmetic where they look at the budget in their household, look at how the bills are calculated and whether there's mistakes in the bills. Maths is everywhere. In any career they do, they need maths. I'm surprised it's not compulsory in year 11 and 12.
It was in the past, a long time ago.
Yeah. But now it's not. And
but I think most students are beginning to realise, you really need
that you
maths
need
if you want to go into tertiary education. Yep.
Correct. Yeah.
Well, this brings us to an end of our episode. That went very quickly, didn't it? There's lots more we can discuss, but unfortunately time has bet us to it. So thank you, Andrew, and thank you, Andre, for coming to this episode. And we thank our viewers, and we'll see you next time. Thank you.
Thank you.